Okay, this is my electromagnetic presentation. One problem with transferring information is I want to know what the weather and traffic are going to be like for my commute to and from work or school. This is a problem because if there's a huge crash or the weather is bad, I may need to take a different route home or leave earlier. One solution to this problem is turning on the FM or AM radio in my car at home or at work. The transfer overview is the kinetic energy is in the radio studio with the broadcasters and the machines, and then the electrical energy is the radio transmitter, and then the other electric energy is the radio tower, and then the radio wave, and then continued the radio wave goes to the car antenna, which is also electric energy, and then the radio tuner in your car is mechanical electric energy that tunes the music that you're listening to a certain frequency so that you can hear it. My input source is a radio station studio. The information that is being input is the weather and traffic report from the radio broadcasters. Input interface. The interface to my device is a radio transmitter and is converted by the kinetic energy, which is the radio broadcaster again, and then it's transmitted to the transmitter, and then that sends it to the radio towers, which sends it out. And then the transmission. The transmitter in my device creates an electromagnetic wave by using a radio transmitter to send waves to the radio tower that relays them to the antenna. So the transmitter relays them to the radio tower, which sends it to your car antenna. And then characteristics of my electromagnetic wave is the common name is radio wave, and the region of the electromagnetic spectrum is right at the front or farthest right, which is right here. The typical frequencies are 3 kHz to 300 GHz. The typical wavelengths are 1 millimeter to 10 kilometers. The speed of the wave is the speed of light, which is almost 300 million meters per second. The distance traveled is 303 trillion kilometers, and the penetrating ability is through most solids. The output reception. The receiver in my device collects the electromagnetic wave by the radio tower sends out the electromagnetic wave to other radio towers or your antenna. The output distribution. My device converts the information by using an antenna that sends a wave that can be tuned and amplified to be able to hear from a radio station. So your car antenna will pick up the electromagnetic wave, or like the electrical and kinetic energy, and then the tuner in your car will tune it to a frequency that you can hear it, and the kinetic energy is your ear. And then this is just an example. The antenna will pick up the wave, and then the tuner will tune it to a frequency that you can hear, and then the detector and amplifier will make it so you can hear it. It will to like a loudness that you can hear it, and then the speaker will project that sound. My factor. Using this information transfer device to solve this problem interacts with the factor of social. The definition of this factor is interactions between groups of people involving issues such as welfare, safety, rights, justice, or class. And then, based on this factor, I believe this is a good use of science because it involves safety, which is why I need to listen to the radio for the weather and traffic report. And then, after researching this topic, the facts I found to support my belief are listening to the radio for weather and traffic reports should decrease my risk of accident due to my proactive knowledge of the circumstances. And then, cultural. Based on this factor, I believe this is not a good use of science because culture doesn't relate to my topic. And after researching this topic, the facts I found to support my belief are culture will not influence anyone to listen to the radio or to not listen to it. And then that's it.